Our lesson today focuses on predicting if a salt solution is acidic, basic, or neutral. You can refer to section 19.5 in your textbook. Let's get started. Let's review what a salt consists of. It consists of an anion from an acid. For example, hydrochloric acid. The chloride ion would be the anion. It also consists of a cation from a base, such as sodium hydroxide, where sodium would be the cation. Salts form from a result of a neutralization reaction between an acid and a base. In this reaction, the salt formed would be sodium chloride, and we would also have water. The resulting solution may be acidic, basic, or neutral. Today, you will learn how to predict whether these salt solutions are acidic, basic, or neutral, and it will all depend on the acid and base involved in the neutralization reaction. To determine the pH, we need to think about what the ions are doing in solution. Some ions will remove hydrogen ion from water. Others may donate hydrogen ions to water. These hydrolyzing salts usually come from one of two scenarios: a strong acid, weak base reaction, or a weak acid, strong base reaction. Our first example deals with a weak acid, ethanoic acid, which is this compound right here, and a strong base, sodium hydroxide, which is shown there. Sodium ethanoate is the salt produced by this weak acid strong base reaction, and that is shown here. Sodium ethanoate ions in solution completely ionize, as you can see by this reaction that I have starred here. Because the ethanoate ion in solution will act as a Bronsted-Lowry base, that means it will accept a hydrogen ion from water, as you can see in this reaction. The water dissociates into OH ions, and the hydrogen from the water attaches onto the ethanoate ion, producing ethanoic acid. Now you'll notice that there's excess OH in this solution now, and so the solution will be basic. It's also called hydrolysis because a hydrogen ion is split off of an H2O molecule or water molecule. So we can say in a weak acid strong base scenario, it produces a basic solution. Our next example is the reaction between a strong acid and a strong base. In this case, we'll be looking at a reaction between a strong base, sodium hydroxide, and a strong acid, hydrochloric acid. In this reaction, sodium chloride is produced, as well as water. In solution, the sodium chloride will dissociate into sodium ions and chloride ions. Both will stay in solution because they have no affinity for water or attraction to water. They will not split water into hydrogen ions or hydroxide ions. The water stays intact, so there's no excess hydrogen ions or hydroxide ions in solution to make this either acidic or basic, so this solution is neutral. So when a strong acid and a strong base react, they produce a salt solution that would be neutral. Our last example is the reaction between a strong acid and a weak base. The strong acid here is hydrochloric acid, and the weak base is NH3, which is ammonia. This reaction produces the salt ammonium chloride and water. The ammonium chloride in solution produces ammonium ions and chloride ions. The ammonium ions in solution act as an acid, and so they actually will donate their hydrogen to water, forming the hydronium ion, as you can see in this reaction which I have starred. This forms ammonia in the water and also hydronium ions, which you know can also be written as H+. Now when you see this reaction, you notice there's excess hydrogen ions in solution, or hydronium ions, and this will actually cause the solution to be acidic. So we can say that when we react a strong acid with a weak base, we will form a salt solution that has excess hydrogen ions, and it causes the solution to be acidic. This slide just shows a summary of all of the reactions that we talked about. A strong acid and a strong base will give us a salt solution that is neutral. A strong acid reacting with a weak base will give us a salt solution that is acidic, and a weak acid reacting with a strong base will give us a salt solution that is basic. Let's practice with these examples. I've listed a salt, and we will determine if the salt solution is acidic, basic, or neutral. Our first example, we have sodium nitrate. If we think about the reaction that produced this salt solution, we would have sodium hydroxide reacting with nitric acid. And if you think back to the strong bases and the strong acids that you needed to memorize, you would know that sodium hydroxide is strong and nitric acid is strong. So we have a strong base and a strong acid reacting to form this sodium nitrate salt, and water, of course. And this salt solution would be neutral. Our second example is sodium nitrite. Again, the reaction would be between a strong base, sodium hydroxide, and a weak acid, nitrous acid. So here we have strong base reacting with a weak acid. In this case, the salt that is produced is sodium nitrite, and sodium nitrite will accept the sodium nitrate salt will break into the sodium ions and the nitrite ions. The nitrite is going to be a hydrogen ion acceptor, so when it is in solution, it is going to pull hydrogens off of water to form the weak acid, and what we're left with is OH ions in solution. So this salt solution will be basic. Our last example is with the salt ammonium sulfate. Ammonium comes from the ammonium hydroxide, and the sulfate ion comes from sulfuric acid. Sulfuric acid is a strong acid, and ammonium hydroxide is a weak base. what's going to happen here is the ammonium ions in solution are going to actually donate a hydrogen ion to water. This will form excess H3O. Sorry, this should be a 3. And those hydronium ions are going to make this salt solution acidic. Your assignment is to complete textbook page 622, numbers 40 and 42, and page 625, number 69. You may have already completed this assignment in class on one of the days that I was out sick, so I would like you to hand in that assignment in the Dropbox. You can take a picture of the assignment if you did it in your notebook, or you can submit it into the Dropbox if you did it on Notability. Either way is fine.